Hey everyone, welcome to my channel. Today we're diving into the fascinating world of magnification, exploring 4 different ways to make things appear bigger and easier to see. We have 4 types of magnification. First, we have the relative size magnification. Second, we have the distance magnification. Third is angular magnification. And fourth is projection magnification. First, we have the relative size magnification. So its formula is RSM is equal to S2 over S1, where S1 is the original size of the object and S2 is the new size of the object. So imagine holding a magnifying glass close to a tiny insect. By increasing the object's size itself, we effectively magnify it. So this is called the relative size. The one that is altered is the size itself. So for example, if we enlarge a picture from 5 to 10 centimeters, what is the RSM? So the solution would be the, the, the new size over the original size. So since the new size is 10 centimeter, we divide it by 5. So we got the 2 times. So RSM is equal to 2 times. So to picture it out, this is the original size, the 5 centimeter, and this is the 10 centimeter. So by doubling the 5 centimeter, we gain the 10 centimeters. So let's proceed with the relative distance magnification, where the formula is RDM is equal to R over D, where R is equal to original working distance and D is equal to new working distance. I don't really know why they use these variables, but let's just uh, let's just familiarize it with R is original, so original, and D is distance, bago na distance, new working distance. So for example, if you hold a book at 40 centimeters initially and then move it to 20 centimeters, what is the RDM? So for the solution, we only have to divide the original over the new. So since our original is 40 centimeters, we divide it with the new, which is the 20. So 40 over 20 is equal to 2 times. So our RDM is 2 times. So to picture it out, this is based from the example. So 40 centimeters is away, so that will make the image smaller. Well, if ang distance is closer, of course, the image will get larger. So to get the relative distance magnification, you just have to divide the 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 original to the new. So original over new. Okay, then we have the total magnification. It is not a type, but only a to know the if kanang doble-doble na ang mga given. So muna siya ang total magnification. TM is equal to relative size magnification times relative distance magnification. So for example, we have the original size and WD of 4M at 60 cm, and new size and working distance of 12M at 30 cm. So we are tasked to find the RSM, RDM, and TM. So for the RSM, simply substitute lang sa S2 and S1. Then we will gain these answers. 3x, RDM is 2x, 2 times. Then total magnification is 6 times. So, sayon-sayon pa siya. Kay same-same pa man siya og kanang mga units. But what if I will give an example that has different units? So for this example, we have the original size and WD of 50 inches at 2m and the new size and WD of 200 cm at 3 feet. Since they are not in the same unit, so you can't kanang dire-diretso, you can't directly calculate it. So what you need to do is to convert a unit here so that they can both be the same at units. So mamili ra ka ani either ang inch or ang cm basta kay same lang sila og units. So for example, ngarita sa RSM magsugod. So RSM is equal to S2 over S1. Ang ato uh, new size is 200 centimeter. Maning new size na to. Then ang ato original size is 50 inches. Okay? So 200 centimeter over 50 inches na siya. But since they have different units, which is cm and inch, so mangita tag way para ang naiisa nila na mo adjust para mo same og unit sa isa. Okay? So for example, atong 50 inches kay ato siya i-convert pa dong sa cm. So 50 inches pilay centimeter sa isa ka inch is 2.54 centimeter. So you just have to multiply it. 50 times 2.54 is equal to 127 centimeter. So balik na sad ka na naman kay value sa ato 50 inches. Muna siya. So 200 divided by 127 is equal to 1.57 times. Okay, so we also have an alternative way. So instead of 50, pwede sa mo kuan sa kaning 200. So same lang ni siya kung it's up to you kung asa ka mas comfortable. Okay, so we have the RSM na. Now we can proceed to the RDM. So pila man ang ato value sa RDM? So ang ato original is 2. Nya ang ato new distance is 3 feet. So 2 meters over 3 feet siya. So ang ato ipa-adjust kay ang 3 feet nga rin 2 meters. So sa 3 feet kay ato na siya ipadung adto sa meters, okay? Ato tagsa-tagsahon. Sa usa ka feet pila ka inches? 12 inches. So na diri sa taas ang inches kay ang inches man nimo goal. Pila na sa dato goal ang centimeters na sad. So pila ka centimeters sa isa ka kuan inch? 2.54. Hangtod maadto siya sa 1 meter. Mo maning final goal nimo. Kay if i-cross out man ni siya. Ching, 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 ching. So mana m lang ang mahabilin ani. So ang 3 feet is equivalent to 0.91 meters. So 2 divided by 0.91 is equal to 2.19 times. Yan, natay alternative way if ever ganahan mo ani. So since we already have the RSM of 1.57 times and RDM of 2.19 times, we can already get the total magnification, which is only the product of the RSM and RDM. So 1.57 times 2.19 is equivalent to 3.44. So you may be wondering, anong multiply man ang total magnification? Why not sum? Nganong dili man siya pwede i-add lang ang kining RSM or RDM? Because that's how magnification works. Muna siya ang tawag na synergistic effect sa kining magnification. You can't just add that numbers. For the third type of magnification, we have the angular magnification, which is composed of two systems, which are the Galilean and the Keplerian telescope systems. The difference between them is that in the Galilean, it is composed of convex objective lens and concave ocular lens. As for the Keplerian, it is composed of two convex for the objective and the ocular lens. The formula for this angular magnification is equal to the dioptric value of the ocular lens over the dioptric value of the objective lens. So this is what the Galilean telescope looks like. So it produces an erect image. As for the Keplerian system, it produces an inverted image. So what is angular magnification in an essence? So unlike the RSM, RDM, and the PM, uh, angular magnification is actually the the ratio between the angular sizes that are produced. So this is our first angle, and this is our second angle. This is for the Keplerian telescope. And for the Galilean, this is the first, and this is the second. So how do we interpret this? So for example, if the angle subtended in the eye is 5 degrees, and we have the angular magnification of 2 times, then we can say that, okay, the angular magnification is 2 times, then we can say that the angle is magnified by 2. So this means that this angle will be 10 degrees. So the main point here is that in angular magnification, it is not actually that it is not that you are enlarging the image, but the angular size, which enlarges what you perceive to that image. It is only the magnification here refers to the relational size of the image. Okay, so let's not dwell more on this concept because this is more on the theoretical optics. So if you want to review for this concept, you may want to revisit our TJO. So let's now proceed for the example of angular magnification. So we have here an example of given minus 20D ocular lens and plus 10 objective lens. So based from the given, what is the type of telescope? So since our ocular lens is minus 20D, that is our Galilean telescope. And the formula of our angular magnification is, what is it? So it is ocular lens over the objective lens. So minus 20 over plus 10 is equal to minus 2x. So you don't use negative magnification because in real practice it is a positive sign. So 2x. So 2 times ang angular magnification ani. Okay. Another example. Given is plus 15 ocular lens and plus 6 objective lens. Since both of them are positive, so the type of telescope for this is our Keplerian telescope. And for the angular magnification, simply substitute. Of course, you have to make the ocular lens the f2. So 15 over our objective lens of 6. So 15 divided by 6 is 2.5 times. Now let's proceed with the distance between two lenses. The distance between two lenses is essentially the length of the telescope. But in this formula, we'll use the d, which stands for separation or distance between two lenses, Our f2 is the focal length of the ocular lens, and f1 focal length of the objective lens. Okay, now let's proceed. So for the given is minus 20 diopter ocular lens and plus 10 objective lens. So this is the same example from above. I think yes, it is the same with the Galilean telescope. So let's solve. So you will want these dioptric values to be a unit of measurement in metric system. So you will want to use the centimeter. So para ma-convert siya into centimeters, you divide it by 100. 100 divided by the focal power. Since f2 is equal to 1 over f2, big F. Okay. Still note that the capitalization matters here in this subject. So the big F denotes for the power, while the small f denotes for the focal length. So now that we know how to convert these powers, so you will just have to substitute it. So 100, since it is centimeters, diba? 100 over 100 over minus 20, and plus 100 over plus 10, which is equivalent to 10 centimeters. So the distance between them is equal to 5 centimeters. So how do we interpret this? Since it is a Galilean telescope with a high minus lens, so unsa man nga to low plus lens anhi? Our low plus lens would be our objective lens, which is the plus 10. And our high minus lens is our minus 20 ocular lens. This may be the eyeglass of the patient. Okay. Or the magnifiers. Or no, not magnifiers. Like the telescope itself, yeah. Okay. So now we have this given. Now we have this given, and then these are the f2 and the f1. So it is deducted ang kining 10 centimeter mo ni ang ato 10 centimeter and this is our 5 centimeter. Okay? So it is subtracted para makit-an ang distance between aning kini na f2 and this f1 here. So 10 minus 5 is equal to 5 centimeter. So we can interpret this that the distance between this low plus lens and the high minus lens is equal to 5 centimeters. So this is also the reason why Galilean telescope tends to be smaller and lighter compared to astronomical telescopes such as the Keplerian telescope. Muna if mag-search mo og picture sa Galilean, mas gagmay ni siya. Like, nanay eyeglass. Klaro naman na eyeglass. So, muna siyang itsura sa eyeglass. So, yeah, muna siya ang Galilean telescope. Like, gamay ra siya. So, another example, let's have the Keplerian system. So the same process lang. Simply substitute the f2, the focal lengths. So 100/15. And then for the objective is 100/6. Simply substitute lang. And then you will arrive with the answer of 23.34 centimeters. So gi-add na add jud siya, no? This is because this is what the Keplerian telescope looks like. So f2 of the objective is, okay, objective lens man ang pamangita is okay, 16.67, and our eyepiece here, ocular lens, is 15. So that is 6.67. So you will want to know the distance between this point to this point. So all you have to do is to add them. So that's why you got the answer of 23.34 centimeters. That's why the Keplerian telescope tends to be longer. Okay, this is an alternative formula for the angular magnification. For those not interested, you may skip this. You may skip this segment and proceed with the projection magnification. Okay, for the alternative formula, since m is equal to f2 over f1, so that means that 1 over f2 divided by 1 over f1 using the reciprocal method. So mahimo siya og f1 over f2. This is also a useful tool when checking for your answer if ever you're unsure with your angular magnification. This is for angular magnification, okay? Angular magnification. Okay, so for example, you now know that your f1 here is equivalent to 16.67. So all you have to do is 16.67 here, and then divide it by f2. What is your f2 here? f2 is equivalent to 6.67. 6.67. So what does this equate to? 16.67 divided by 6.67 is equal to, wait, is equal to 2.5 times. So same ra ba siya sa ato nakuha kanina? Let's check. Asa man to? Okay, mamanin siya, di ba? Okay, sa Keplerian man to. So we got the same answer from our previous example, 2.5 times. So you can use this if ganahan mo. Okay, this is another example. This uses the Galilean. Yeah, sa revised or sa shortcut. Di man siya matawag na shortcut. Like, another solution lang siya. Pause lang if ganahan mo try sa. Okay. Now, let's proceed with the fourth and final type of magnification, which is the projection magnification. Its formula is PM is equals to IS over OS. ISOs. You have to remember the ISOs. PM is equals to ISOs. Where IS is your image size and OS is the object size. So, based from this diagram, asa dring image size na to, object size. Muna siya ang ato object size. Nya mo ni siyang ato image size. Okay. Bali, nadako na ang image size. Makes sense because if ang OS, if ihimo na siya OS over IS, mugamay na, di ba? Pasabutan na kay ni minify. Pero since projection magnification mata, padako na. A positive value indicates that more than one value indicates that it is enlarging. Okay. So for example, solve for the projection magnification if your object size is 10 by 30 centimeters and the projected image size is 2 by 3. So all you have to do is to use the PM is equals to ISOs. So IS nato is pila man 2 by 3. Okay. So this is another example pero let's go on sa one by one lang. So PM is equals to IAS over OS. So what you want to do is imo siya same og unit. So it's either imo siya ipadung sa cm duha or imo siya ipadung sa meters duha. For convention, pwede lang ang meter lang. So our image size here is 2 by 3. So IS is equals to 2 by 3. No need to convert since meter naman siya. So natay IS of 6. As for the OS, object size, since it is in 10 by 30 centimeter, you will want to convert them first to meters each. So 10 divided by 100 since centimeter to meter man is equal to 0.1 and 30 is equal to 0.3, which is equal to 0.03. And then following dpm is equals to ISOs, so P6 over 0.03. So 6 divided by 0.03 is 200. And don't forget the times sign. 200 times. Okay. So this can be interpreted that referring from the object size, the projected image is 200 times larger than the object size itself. Then, that's it. So now let's proceed for a quiz. Just pause the video so that you can answer well on your seats. Okay. This is number one. 2, and 3. Okay, 3 items lang. So that's it. Thank you. And if you have any questions, feel free to ask me. Okay, I hope you have learned something from this lesson, and thank you and God bless. These are the references that I've used, and bye bye.